I welcome you to today's lesson, that is the chemistry lesson. My name is Java. Today we'll be looking at the more concept. Our topic is more concept. More concept. That is our topic for today. Our subtopic, which we are going to concentrate on, is on the empirical and the molecular formula. This is what we are going to be looking at today, empirical and the molecular formula. So by the end of today's lesson, we must be able to, one, describe an empirical formula. We must be able to describe an empirical formula. We also must be able to describe the molecular formula. We must be able to describe the molecular formula. Then our third objective, we must be able to calculate, calculate or determine the empirical and molecular formula, of different compounds, So these are our three objectives for today. We should be able to describe what an empirical formula is. We should also be able to describe or define the molecular formula. And finally, we should be in the position of calculating the empirical and the molecular formula of different compounds. This is what we are going to be looking at today. We'll start by looking at the empirical formula. Hope we have gotten the objectives for today. Three objectives. Okay. We'll start looking at the empirical formula. Okay. Empirical formula. What is an empirical formula? Yes, Tantola?
An empirical formula is a formula which shows the smallest ratio of atoms in a given compound.
Very good. An empirical formula, it is simply a formula which shows the smallest ratio of atoms in a given compound. In other words, it represents the lowest amount of atoms in a given compound. This is what is known as an empirical formula. An empirical formula, it is a formula which shows the smallest ratio of atoms in a given compound. We can look at this definition which we have here on the chart. Okay. Empirical formula. Okay. This is the formula which shows the atoms present in a compound in their simplest ratio. The formula which shows the atoms present in a given compound in their smallest ratio. This is what is known as an empirical formula. Are we okay? Okay. Now, when we are determining the empirical formula, we have rules or steps that we normally follow, which will help us to calculate the empirical as well as molecular formula. Okay. Steps to calculate empirical formula. What are the steps that we have to follow when calculating the empirical formula? First step, you write the symbols of the combining elements. Okay? Write the symbols of the combining elements. Step number 2, you write the combining percentages by mass. You will be given the combining percentages by mass, as we'll be looking at some examples. You write them under each of those symbols of the elements which are in the given compound. Then you divide each element percentage by the mass number of the same atom or the same element. Okay. After you have divided that, you will find your ratios. We have to divide the answer by the smallest number in the ratio. This is after you have divided. Okay? And finally, after you get your ratios, you can now write down the ratio of the empirical formula. How many rules do we follow or steps? 5. 5 steps. Are we okay? Write the symbol of the combining elements. Write the combining percentage by mass. Divide each element percentage by mass number. Then divide the answer by the smallest number in the ratio. And finally, you write down the formula of the compound given. Are we okay?
Yes.
Let's look at an example. An example on finding the empirical formula. Okay. Is find the empirical formula. Empirical formula. Find the empirical formula of a compound. With the composition. Okay? Composition of 80% copper, and 20% sulfur. Okay? This is our question. This is our first question, our first exam. Find the empirical formula of a compound with the composition of 80% copper and 20% sulfur. This is our question. So, solution. Okay? Solution. The first step we have gone through is we should write the symbols of the combining what? Elements. Symbols of the combining elements. So, what are the elements that we have in this compound? There is copper and sulfur. So you write down the symbols. So we are going to have copper, the other one is sulfur, like that. Okay? Write down the symbols, copper and sulfur. Right. Then you look at the question. What is the percentage of copper? What is the percentage of copper? There is 80%. Whereas sulfur, there is what? 20%. Like that. You write them under that. Okay? This is their percentages. 80 and 20%. Okay? Then, what is the third thing? We have said divide the percentages by the mass numbers. Mass number. When you look on the periodic table, what is the mass number for copper? Yes, Jennifer Banda? 64. The mass number for copper is 64. You write 64 like that there. Are we okay? Then you come to sulfur. Again, sulfur, you look on the periodic table. What is the mass number for sulfur on the table. Yes, based on there, 32. 32. So you write 32 like that. Are you okay?
Yes.
So here, this is you are dividing by mass number. Divide by mass number. So we are dividing this by the mass number. Also 20 by mass number, which is 32. Are we okay? Now, what is 80 divided by 64? 80 divided by 64. Yes, the way can you know?
1.25.
1.25. Okay? 1.25. What is it? 20 divided by 32. Yes, Tarandila?
0.625.
0.625. Are we okay? So these are the ratios we have found. So we have, when you divide 80 divided by 64, it gives you 1.25. When you divide 20 by 32, you have 0.625. Are we okay? So I'll write these values there on top. Okay? So we have, we still have, this is copper. We have copper, and we also have silver. So here we have 1.25 to, this one is 0.625. Are we okay? Then the fourth rule is you divide by the smallest of the values. So between 1.25 and 0.625, which one is the smallest? Which one is the smallest? Which one is the smallest? Yes.
0.265.
Okay, 0.625. So you divide by 0.625. Between this side, 0.625. Are we clear? Yes. So when you divide 1.25 divided by 0.625, what are we getting? What are we getting? What are we getting? Okay? I want someone else. Yes. Alvera? 2. We get 2. Okay? It's 2. 2. Then 0.625 divided by 0.625. Obviously the answer is 1. So you write 1. Okay? So what we have here, these are the ratios. Okay? These are the ratios. Which means in this compound there is 2 copper and 1 sulfur. Therefore, okay, empirical formula is simply copper, you write copper like that, then 2, this 2 which is here, and the sulfur like that. So this is it, the empirical formula. That's it, the empirical formula. Are we okay?
Yes.
This is how you go about it in calculating the empirical formula. Okay? First we identified the elements which are in this compound, which is copper and the sulfur. Then we identified the percentage abundances by mass. We have 80% copper, 20% sulfur. So we have written 80 and 20. Okay? From there, we have divided these values by their mass numbers. When you look on the periodic table, the mass number for copper is 64 and the mass number for sulfur is 32. Okay? When you divide 80 divided by 64, we end up with 1.25. Then when you divide 20 by 32, you end up with 0.625. Then, when you look at, you find this one, you finally divide by the smallest between the two. So, the smallest here is 0.625. That's why we have come to this point now. You divide 1.25 divided by 0.625, it has given us 2. It has given us 2. Then 0.625 divided by 0.625, it has given us 1. Okay. Therefore, this is the ratios. Okay. It simply means in this compound we have got 2 copper. This is C. Okay. We have got copper, then put the 2, this one we found here, then S, just 1. That is it, our final answer. Is it clear?
Yes.
Okay. Let's look at another example. A compound was found to contain 29.4% calcium, 23.5% sulfur, and 47.1% oxygen. What is the empirical formula of the compound? Are we okay? Okay. Let's look at the solution. Okay? Let's look at the solution. Okay. First of all, we identify the elements which are in this compound. We have calcium. This calcium here. Are you okay? We have calcium. So we write calcium. Write calcium. Then we also have sulfur. Then we have oxygen, like this. Okay. These are the elements that we have in this compound. We have calcium, we have sulfur, we also have oxygen. Okay, that's the first stage. Are we okay?
Yes.
What is the percentage by mass of calcium? We have been told is 29.4. So uniting 29.4 and the calcium to 4 sulfur, it is 23.5 to oxygen, it is 47.1. This is what we have. The second step, divide each of these by the mass numbers of these. So, on the periodic table, the mass number for calcium is what? Yes, Mwape?
40.
Calcium is 40. Then sulfur, we have already seen it there, it is 32. Then oxygen is what? Yes.
16.
16. Okay. 16. We divide. 29.4 divided by 40. 29.4 divided by 40. 29.4 divided by 40. Units?
0.735.
0.735 to, okay? So here you are dividing by mass, right? Divide, okay, by mass. Divide by mass, okay? 23.5 divided by 32. 3.5 divided by 32. FM, what is the answer?
0.734.
0.734. That's all?
No.
It continues.
Yes.
Okay, we'll put it to 3 decimal places. Then 47.1 divided by 16. 47.1 divided by 16. Yes? The one next to Eunice?
2.94375.
2.943. 75. Okay? So we can even put this one as 2.44, isn't it?
Yes.
2.44. 2.44. So that we maintain the decimal numbers. So when you look at this one, which one is the smallest here? Which one is the smallest value that we have here? So what I will do, I will write this up there so that you can see them properly. Okay? So we have calcium, we have calcium, we have sulfur, we have oxygen. Okay? So the values is 0.735 to 0.73334 to 2.944. Are we okay? Obvious, the smallest of these is what? 0.734. So 0.734. 0.734. Are we okay? So when you divide 0.735 divided by 0.734 to the nearest whole number, the answer is yes? 1. So we have 1 here, 2, obvious here is also 1, then 2, sulfur now, how many oxygen? 2.944 divided by 0.734. Yes, Josephine Banda? 4. We have 4. So this is it, what we have. So these are the ratios. These are the ratios. So we have got one more of calcium, one more of sulfur, and 4 of what? Of oxygen. So finally, the empirical formula will be calcium, then sulfur, or we have calcium, sulfur, or 4, which is calcium sulfate. That is calcium sulfate. This is how we can find the empirical formulas of different compounds by following these simple steps. Any question? We are okay. Okay. Let's progress to molecular formula. What is the molecular formula of a compound? Yes, best and
Molecular formula is the formula which gives the actual number of atoms in a given compound.
A molecular formula, so we simply say this is a formula. This is a formula that shows the actual, okay, actual number of atoms present, okay, in a given compound. This is what we call a molecular formula. Okay? This is a formula that shows the actual number of atoms present in a given compound. This is what we mean by the term molecular formula. Okay? Now, to find the molecular formula, we use the formula. Molecular formula is equal to empirical formula multiplied by the multiple whole number n. Multiplied by the multiple whole number n. That is the formula we use to find the molecular formula. Okay? Now, we know what EF is standing for. It's the empirical formula.
Yes.
This multiple whole number, we have calculated. Okay? The multiple whole number n is equal to molecular mass. Okay? Molecular mass. Okay? Relative molecular mass of a compound. Divide it by the relative, okay, empirical molecular mass. Okay, this is what we use to find N. Okay, the multiple whole number N is equal to relative molecular mass of a compound divided by the relative empirical formula mass. Okay, empirical molecular mass. This is how we calculate the molecular formula. Molecular formula is equal to empirical formula mass, multiply this one by the multiple whole number N. Multiply it by the multiple whole number N. Now, how do we calculate this multiple whole number? The multiple whole number N is equal to the relative molecular mass of a compound divided by the relative empirical formula mass. Empirical formula mass. This is what we do. Meaning, therefore, you cannot find the molecular formula of a compound if you don't have the empirical formula. Okay, so which means, therefore, when I'm given a question where they want you to find the molecular formula, the first thing you calculate the empirical formula. Find the empirical formula. After you've found the empirical formula, you can now go further by finding the multiple whole number N. This one, when you find the multiple whole number N, you can now put it there and multiply the empirical formula by multiple whole number N. It will give us the molecular formula. Are we okay, learners?
Yes.
Okay, let's look at it. First example on the empirical formula. Okay. Example 1. Example 1. Okay. What is the example say? The empirical formula. The empirical formula. The empirical formula of a compound. Of a compound is C2H4O. Okay? Then its relative molecular mass is 88. Okay? Its relative molecular mass is 88. Okay. Then, full stop. Then the question is, find the molecular formula. Okay? Find the molecular formula. Okay. Find the molecular formula. This is the question we have. Okay. Now, the beauty of this question is, at least they are already giving us the empirical formula, isn't it?
Yes.
We have the empirical formula. What are we supposed to find only? The multiple whole number N. In this question, in this formula, are we okay? So, let's look at the solution for this question. Solution. Okay. First thing that we know is molecular formula is equal to the empirical formula multiplied by the multiple whole number N. We already have the empirical formula. The question has already given us the empirical formula of a compound is C2H4O. Okay. Then the relative molecular mass of this compound is 88. Then what is the molecular formula? So what we do here, the first step here, we are going to do is finding the multiple whole number N. Right? The multiple whole number N is equal to relative molecular mass, okay? Divide this by relative empirical empirical formula mass. Divided by relative empirical formula mass. Okay? So, what is the relative molecular mass? In the question, we have been told it is 8. So you put 8 there, divide this by the relative empirical formula mass. What is our empirical formula we have been given? First, let's bring our empirical formula here. C2H4O. Okay? C2H4O. H4O. Now, we know this is, we don't need this empirical formula here. We need the mass, the molecular, the relative empirical formula mass. Not the empirical formula itself, but the mass. So, we'll remove this one. We have to calculate the empirical molecular mass, which we can calculate here. Okay? In this compound, there are how many carbons? 2. There are 2 carbons, eh? Yes. Okay, we can put it in here. So, 2. What is the mass number for carbon on the periodic table? 12. Okay? Then 12 times 2. What's the answer? 24. So we have 24 plus hydrogen. On the periodic table, the mass is 1. Then 1 times 4, it gives us back 4. So plus 4. Then oxygen is 16. So we write 16 there. So we bring it further down. So it will be 8 divided by now 24 plus 4. That is 28. 28 plus 16. What is it? The answer? 20. Yes, Mary?
44.
44. We have 44. Okay. Then 88 divided by 44. The answer is 2. We have 2. This is our multiple whole number n. We have found here as 2. Are we clear, girls?
Yes.
Okay. Now, we know this formula. Molecular formula is equal to empirical formula multiplied by the multiple whole number n. The multiple whole number n we have found. So it's just a matter of fixing it now in the formula. Are we okay? Yes. So molecular formula is equal to empirical formula multiplied by the multiple whole number n. So you write down your empirical formula, which is C2H4O multiplied by 2. When there is n, you put 2. Then you start multiplying inside. So C, 2 times 2, 4. You write your H, 4 times 2, 8. Then O, 2. This is our molecular formula. This is our molecular formula. Is it clear?
Yes.
Okay. So this is how you calculate the molecular formula. So the first thing you have to find, after finding the empirical formula, you calculate your multiple whole number n. After finding your multiple whole number n, substitute it now in the formula. Molecular formula is equal to empirical formula multiplied by the multiple whole number n. So that you finally get your empirical formula. This is our empirical formula. Are we okay?
Yes.
Okay. So now I'll give you a question which you have to attempt, then later on we give the answer as a class. Example number 2. Example 2 is as follows. A compound contains 40% carbon. Okay? It contains 40% carbon, 6.7% hydrogen, and the rest being oxygen. The rest being oxygen. Okay. hydrogen, the rest being oxygen. Okay? The question is find the molecular formula. Find the molecular formula. This is our question. A compound contains 40% carbon, 6.7% hydrogen, and the rest being oxygen. Then the question says, find the molecular formula. Find the molecular formula. That is our question number 2. Someone come and solve for us. In it, you start attempting. Go through it. Find the molecular formula of the compound if it's relative. Okay? Molecular mass is 180. If it's relative, molecular mass is 180. That is the relative molecular mass. Okay. We have a minute to go. We have a minute to go. Someone to come and solve the question for us.
So first, we subtract the percentages we've been given from 100. When we add this, when we do 100 minus 46.7, we get 53.3. So this is the percentage of oxygen in this compound. Then now we find the empirical formula. So first we write the ratios: carbon to hydrogen to oxygen. Then there is 40% of carbon, so we put the 40 here. Then there is 6.7% of hydrogen. And then we have 53.3% of oxygen. Then we divide by the mass numbers. So the mass number for carbon is 12. The mass number for hydrogen is 1. And the mass number for oxygen is 16. So when you divide 40 by 12, it gives us 3.3. 6.7 divided by 1 gives us 6.7. And then 53.3 divided by 16 gives us 3.3. Then now we have this. We divide by the smaller one, and here the smallest is 3.3. So we divide by 3.3. Even this one divided by 3.3. Even this one divided by 3.3. Yes. When you divide 3.3 by 3.3, you get 1. 6.7 divided by 3.3. When you round it off to one decimal place, you get 2. Sorry, to one whole number. And then 3.3 divided by 3.3 also gives us 1. This is carbon, hydrogen, and oxygen. So it means the empirical formula becomes CH2O. Then now, the question is telling us to find the molecular formula. So we need to use this. Yes, the molecular formula is equal to the empirical formula multiplied by the whole number multiple. So we don't know this one. So we have to find it first. Find that the whole number multiple, we do molecular mass over relative empirical mass. Then, the molecular mass we've been given is 180 in the equation. And then we look at the relative empirical mass. So we go back to the empirical formula. The mass number for carbon is 12, plus the mass number for hydrogen is 1. And since there are 2 there, we put 2. Plus the mass number for oxygen, which is 16. So this would be 180 divided by 30, which gives us 6. So it means our multiple is 6. Now we have the multiple, we have the empirical formula, we can find the molecular formula. So we write the formula like this. Molecular formula is equal to empirical formula multiplied by the whole number multiple. Then our empirical formula is CH2. Then the whole number multiple is 6. Then we multiply. So this 6 we multiply by each of these. So it will become C6. H 6 multiplied by 6 multiplied by 2, 12. And then O multiplied by 6 becomes this. So this is the molecular formula for the compound.
How to find the molecular formula? The first thing, you have to calculate the empirical formula. Now, the question had a trap to make you fail. It said it gave you the percentage abundances for carbon and oxygen and hydrogen. Oxygen was missing. You were just told that the rest being what? Oxygen. And we know that percentage is always out of 100. That's why to find the mass, the percentage composition for oxygen, you subtract the percentages given from 100, which she has done here, okay? To find the percentage of oxygen, you add this plus that one, then subtract from 100, giving us this 53.3, which was very correct. Okay, so when you are given such question, don't become stuck. All what you have to do, to find the mass for the percentage for the rest, add what you have been given, then subtract from 100. This is, from there, we have to find the empirical formula. She has followed all the steps up to the ratios, okay? So this is our ratio, okay? The ratio of the moles in this compound. There is 1 carbon, 2 hydrogen, and 1 oxygen, thereby giving us this one as our empirical formula. So this is our empirical formula. Empirical formula is this one, okay? The question did not ask us about the empirical formula. It asks us about the molecular formula. You can't find the molecular formula before finding the empirical formula. Okay, so you have to go through that stage. Although in the question there's no way to say define the empirical formula, but you can't find the molecular formula without the empirical formula. Molecular formula is equal to empirical formula multiplied by the multiple whole number n. This multiple whole number n, we have been given the formula which is here, which is correct. Multiple whole number n is equal to molecular formula mass divided by the relative empirical mass. The molecular formula we have been given, the mass was 180. Then add the mass numbers for all the elements present in the compound. So we have got 1 carbon, 2 hydrogen, and 1 oxygen. You add them. Carbon is 12, oxygen is 1, multiplied by 2, giving us 2. Hydrogen is 1, multiplied by 2, giving us 2. Then oxygen is the mass number. These numbers we are using here, 16 and 12 and 1. we are getting them from the periodic table. They are already there on the periodic table. So when you add all these, it gives us 30. So meaning we have 180 divided by 30, giving us 6. Then this is our multiple whole number n. Then you bring the multiple whole number n back in the formula. Molecular formula is equal to empirical formula multiplied by the multiple whole number n. The empirical formula is CH2O. And the multiple whole number n is 6, multiplied by everything inside. So here there is 1, okay? 1 carbon, okay? So 1 times 6 giving us this 6. 2 times 6 giving us 4. Here 1 times 6 giving us 6. So this is our molecular formula given. Are we clear? So for today's lesson 1, looking at our objectives, we have defined or described the molecular formula as well as the empirical formula. And we have also calculated the molecular formula and the empirical formula. At this point, we have come to the end of our chemistry lesson for today. From me, Rolf Java, and on behalf of the TV production crew, is bye for now, up to next time when we meet.